Welcome to today's lesson. So far we've been dealing with probability and we've looked at various ways in which we represent probability. The first way we looked at was dealing with the theoretical probability, whereby we said the theoretical probability is simply the actual figure that is required for that given probability or given occasion. Then the next type of probability we looked at was the experimental probability, where with the experimental probability we said that various trials are taken into place, or we carry out various trials, then out of the trials we get the probabilities from those given trials. Then we looked at whereby we are combining the events, and when we are having complementary events taking place, we looked at various terms that we use in describing the various probabilities. Our today's lesson is whereby we are going to represent probabilities using Venn diagrams and a two-way table. So we could have another way of representing probability, that is using the Venn diagrams or the two-way tables. So we start with the two-way tables and find out how is this two-way table represented. So our first part, we are looking at the two-way table. So a two-way table simply lists two or more outcomes in different categories. So you are having different categories, not the same category, but different categories. For instance, you could be having a table that is showing various behaviors of animals, that there are those animals that eat meat, there are those animals that do not eat meat. At the same time, they have different sleeping habits. There are those animals that will sleep during the day, but we have those animals that will not sleep during the day. Instead, they will sleep during the night. So you can have different categories of behaviors of different events being represented in a table form. So we look at it using these examples. So we consider this table. So this is the table we have. And in this table, it is showing the sleeping and eating habits of different animals in a zoo. So we are having animals that eat meat and sleep during the day. They eat meat but also sleep during the day. In that zoo are 20. We have those ones that don't eat meat but sleep during the day. In that given zoo, we have 12. Then in total, we have 32. The next category is those animals that eat meat but sleep during the night. We have 40. Then we have those ones that don't eat meat but sleep at night. We are having 28, which gives us a total of 68. So in total, we are having 100 animals. At this place, we have 40, and here we have 60. So those are the totals we have. We are considering that table, and from this table, we can use it to answer various questions. So the first question is, So we are having two categories of animals in this case. We have those animals that sleep during the day, and we have those ones that sleep only at night. So we are being asked for an animal selected randomly from this group of animals in this given zoo. We are supposed to get the probability that it sleeps only at night. So we need to know which animals are sleeping only at night, regardless of whatever they are eating, but they sleep only at night. So the animals that sleep only at night are found in these columns. So we have that, and we also have that. So this one sleeps at night but eats meat. This one sleeps at night but no meat. So what does it mean? We just need the animals that sleep at night regardless of whatever they are eating. So it means the total of animals that sleep at night is 40 plus 28. And 40 plus 28 gives us 68. So the probability that an animal selected at random from this given zoo sleeps only at night is a total of 68. That is the favorable outcome. The number of favorable outcome is 68 over the total number of animals. The total number of animals in this given zoo is 100. So we have 68 over 100 as our probability of the animal sleeping at night. We can simplify our fraction, and 68 over 100, 2 into 68, that is 34. 2 into 100, we have 50. 2 into 34, we have 17. And 2 into 50, we have 28. So we get that when we simplify 68 over 100, we are simply getting 17 over 25. So from this table, you are also supposed to get the probability that this animal eats meat or sleeps during the day. So we have two options here. It is either we are choosing an animal that eats meat or that animal that sleeps during the day. So we need to find out which animals eat meat from this given table and which animals sleep during, or how many animals sleep during the day, and how many animals eat meat from this given table. So we discover that the animals that eat meat are found in these columns. So we are having 20 animals eating meat and sleeping during the day. We have 40 animals eating meat, but they sleep during the night. So in total, animals that eat meat are 60. So we are having 60 animals eat meat, but you have another option that they sleep during the day. So we find out, have we covered all the animals that sleep during the day? So we are having sleeping during the day, and we discover that we've only covered 20 in these animals that eat meat. But also we have 12 as animals that sleep during the day. So it means we have to get the total, the animals that eat meat plus those animals that sleep during the day. So we find that the total of animals that either eat meat or sleep during the day is 72. So what does it mean? Probability of animals that eat meat and or sleep during the day will simply be 72 over the total number of animals in that given zoo, which is 100. So when we simplify, we have 36 over 50, that is by 2. Then by 2 we have 18 out of 25. So the probability that the animal selected at random will either eat meat or sleep during the day is 18 out of 25. So we are having, if an animal is selected at random and it eats meat, what is the probability that it sleeps during the day? So the condition in this probability is that the animal that is selected eats meat. So we find out from our table how many animals eat meat, and we get that a total of 60 animals from this table will eat meat. So we are having 60 animals from that table eat meat. But the second condition in the question is, what is the probability that this animal that eats meat that has been selected also sleeps during the day? So we need to find out which animals sleep during the day among the animals that eat meat. So we are having the animals that sleep during the day are 20. So it means probability that the animal selected eats meat and sleeps during the day will be given by the animals that eat meat and sleep during the day are 20 over the total of the animals that eat meat in that given zoo is 60. So we find that 0 and 0 cancels out. 2 over 6, if we simplify, we are getting 1 over 3 as the probability of that given question. So the next question, what is the probability that an animal that sleeps during the day does not eat meat? So we are having animals that sleep during the day. We find out what is the total number of animals that sleep during the day. So the animals that sleep during the day, in total, we have 32 animals that sleep during the day. So the total of animals that sleep during the day in this zoo are 32. The question is, what is the probability that the animal that is selected sleeps during the day but does not eat meat? So we need to know, among these animals, among the 32 animals that sleep during the day, how many of them do not eat meat? And we discover that from the table, 12 of these animals do not eat meat. So it means the probability that the animal selected sleeps during the day and does not eat meat will be obtained by the favorable outcomes, which is 12, divided by the total number of outcomes, that is 32. So if we simplify 12 over 32, 2 into 12 is 6, 2 into 32, we are having 16. Still we can simplify further, 2 into 6, that is 3, 2 into 16, we have 8. So it means the probability in this given zoo that the animal picked at random will sleep during the day and will not eat meat will be obtained by 3 over 8. So we find that the two-way table just helps us to make our calculation easier, to get it makes the working of the probability easier, so that after you've carried out your experiment, you can simply represent the data that you've obtained in a two-way table, and after you've represented the data in the two-way table, it makes your calculation easier in finding whichever probability you want to get in that given table. Example 2. So that is the question we have. Copy and complete the two-way table below by writing the missing totals. That is part A of the question. So we have those who like banana, dislike banana, then we have like apples and they dislike apples. So we have, in this case, the first row we have 30 plus 10 to get a total of 40. In this row, we have 10 plus 20. In the column, we have 10 plus 20 to get a total of 30. So we find that the totals that are missing in this table is 40 and 30. Then part B of the question. So how many people like both apples and bananas? So we simply move with the rows and column to find out. We have those who like bananas, we have those who like apples. So we find that they are in these categories. Those who like both bananas and apples will be found in these at this point. So we find that the number of people who like both apples and bananas is 30. Part C is how many people in this group dislike both apples and bananas from that given table. So we find out those who dislike apples, those who dislike bananas. Then we find that the number of people who dislike both apples and bananas will be 20. How many people participated in this survey? The total number of people that participated in the survey will be obtained in that total column. So we find that we are having a total of 75 people who participated in the survey. So we are having part E of the question. We find the probability that a person selected at random dislikes bananas. So we need to find out how many people dislike bananas. Remember, the total number of people who are in this interview is 75. So out of the 75 people, we have those who like bananas, we have those who do not like bananas, we have those who like apples, and we have those who dislike apples. So we need to find out from our table how many people dislike bananas. And we find that the number of people who dislike bananas are 35. So 35 people do not like bananas, and in our survey we have a total of 75 people who participated in that given survey. So it means the probability of choosing a person who dislikes bananas will simply be obtained by 35 out of 75. Then we go ahead and simplify our fraction. So 5 into 35, that is 7. 5 into 75, we have 5 into 7, 1. Into 25, that is 5. So we get that the probability of picking a person who dislikes banana from our data will be 7 out of 15. The question then comes, is it possible that this person that has been chosen in this given event will like apples and at the same time dislike those apples? And we find that it is not possible. This person, if the person likes apples, there is no way he or she will dislike the same apples. So this event means that if this person likes apples, then there is no option of disliking the apple. What does it mean? That the one event, if one of the event happens, then there is no possibility of the other event taking place. So this means that we have a type of event that is known as a mutually exclusive event. So we need to know, what do we mean by mutually exclusive events? So when you're having two events and they cannot occur at the same time, then the two events are referred to as mutually exclusive events, in that the occurrence of one event will definitely hinder the occurrence of the other event. They can never occur at the same time. So it means those types of events are referred to as mutually exclusive events. And an example we've just looked at is that there is no way a person will like apples at the same time dislike the same apples. So if the person likes the apples, then it means there is no possibility of disliking the same apple. So it means that they are mutually exclusive. So we are having a survey that was carried out on a group of students who own mobile phones to find out who pays their bills. So we have boys, we have girls, then we have those who pay their own bill and those who do not pay their own bill. So we find that out of the survey that was carried out of 26 students, 4 boys pay their own bill, 7 girls pay their own bill. Then those who do not pay, 8 boys do not pay their own bill, then 7 girls do not pay their own bill. So out of this survey, we find that a total of 12 boys in this survey, we have a total of 12 boys and we have a total of 14 girls. Out of this survey, a total of 11 students pay their own bill and 15 students do not pay their own bill. So the question is, we need to find out how many students participated in this survey. So to get the total number of students who participated in the survey will simply be obtained by finding out on the total column what is the total of these students who are engaged in the survey, and we get that from the total column. What we have as the total is 26. So it means a total of 26 students participated in the survey. The second question. How many participants from this table were boys? On the boys column, we are having 4 who pay their own bill, 8 who do not pay their own bill. So a total of 4 plus 8, which gives us 12 boys. So how many students from the table will pay their own bill? So 4 boys pay their own bill, 7 girls pay their own bill. So a total of 4 plus 7, which gives us 11 students who pay their own bill. So next we get the probabilities in each situation. So the following situations are the ones we need to get their probabilities. So the first question, find the probability that a randomly selected participant is a boy who pays his own bill. So the first condition is that the person we are choosing should be a boy, and in addition to the fact that this person that has been selected is a boy, is that the boy pays his own bill. So in this case, we find out from this column of boys, we find that we have 4 boys who pay their own bill, and we had a total of 26 participants in this given survey. So it means the probability that the person selected is a boy and pays his own bill will be obtained by 4 out of the total participants in the survey, which was 26. So 4 over 26, if we simplify, we are simply getting 2 out of 13. So that 2 into 4, that is 2. 2 into 26, we get 13. So we get that the probability that a student selected at random will be a boy who pays his own bill, will be 4 out of 26. If we simplify, we are getting 2/13. Part 2 is the probability that the student selected is a girl who pays her own bill. So we need to get the probability that the student selected is a girl who pays her own bill. So we find out the girls who pay their own bill, and we get that from this row of the girls who pay their own bill, we have 7 girls who pay their own bill out of a total of 26 students. So we get that the probability will be 7/26 as the probability of girls who pay their own bill. Then part 3 of the question is that we find the probability that the student picked is a girl. So how do we get from this table that the student who has been picked is a girl? It doesn't matter if this girl is paying her own bill or the girl does not pay her bills. So we find out a total of how many girls were interviewed, or how many girls in total participated in this given survey. And we get that 7 girls pay their own bill, 7 girls do not pay their own bill, a total of 14 girls in the survey. So it means the probability that any student picked at random will be a girl will be obtained by 14 out of 26. If we simplify, 2 into 14 is 7, 2 into 26 is 13. So we get the probability that the student picked will be a girl is 7 out of 13. Then next, we are supposed to get the probability that the student picked does not pay their bill. So what is the probability that the student picked does not pay their bill? It doesn't matter if the student is a boy or a girl, but whatever we are looking for, who are these students who do not pay their bill? Then we find out that 8 boys do not pay bills, 7 girls do not pay bills. So we have a total of 15 students who do not pay their bills. So what is the probability? Probability will be obtained by 15 out of a total of 26 students. So the probability that the student selected does not pay their bill will be 15/26 as the probability of those students who do not pay their own bill. So as I said earlier, the two-way table simply helps us to make the probability working easier. After the survey has been carried out, you can simply represent your data in a two-way table. Then out of the two-way table, go ahead and find the various probabilities you want in each and every situation. So another way of representing probability after an experiment has been carried out is using the Venn diagrams. So after you've represented your data in a two-way table, you can simply transfer the two-way table into a Venn diagram. A Venn diagram is simply a pictorial representation of a two-way table without the totals in a row or a column. So where the two-way table, we were writing the totals in a row or a column form, but now with a Venn diagram, we are simply using representation. We are drawing some pictures to represent the given survey. For instance, we can use this table to come up with a Venn diagram. So we use these details for us to come up with a Venn diagram. So we are having the detail in a two-way table, and I want to transfer my detail in a two-way table into a Venn diagram. So we have those people who like tea. Then we have those ones who don't like tea. At the same time, we have those who like coffee and those who don't like coffee. So from the table, we have 20 who like both coffee and tea. We have 15 who don't like coffee. We have 10 who don't like coffee but like tea. Then we have 15 who don't like both tea and coffee. So in total, in this side, we have 35, we have 25. We have 30 and 30, so we have a total of 60 people who are participating in this given interview. Just a minute. Yeah, we have a total of 60. So if I need to transfer my data, this is a two-way table. And from the two-way table, I need to find the data for I need to draw a Venn diagram. This is a two-way table that I have. From this two-way table, I draw my Venn diagram. So this is how the Venn diagram looks like. We find that we have two events. So I'll draw two circles representing the two events. Then on one side, we have those who like coffee. Then we have those ones who like tea on the other side. So what is happening is the circle on the right hand side is representing those people who like tea. The circle on the left hand side is representing those people who like coffee. So we find out how many people from this table just like tea only. So they like tea but they don't like coffee. We find that those who like tea and don't like coffee are 10. So I'll indicate the digits on the circle for those who like tea only. They don't like coffee, but they like tea. Then we have those people who like coffee, but don't like tea. And we find that those people who like coffee, but don't like tea are 15. So we indicate them on that side. 15 people who like coffee, but don't like tea. But we have people who like both coffee and tea. So those who like both coffee and tea, we write them at the point where the two circles are intersecting. So the point where the two circles are intersecting gives us the number of people who like both coffee and tea. So I write the 20 at the point of intersection. So we have 20. Then we have those who are neutral. They don't like coffee, they don't like tea. So how do I indicate these people who don't like coffee and don't like tea? In my diagram, it will simply be shown outside the circles. They don't participate, they don't belong to any of the group. So they are not among those people who like coffee, they are not among who like tea, but they don't like both tea and coffee. And we find that those people who don't like both tea and coffee were 15. So we write our 15 outside the two circles, but it is surrounded by that given frame. So we find that I've done a pictorial representation of my two-way table. This pictorial representation that has been done here is what is known as a Venn diagram. So Venn diagrams can also be used in explaining or calculating the various probabilities in a given situation. So once you've drawn the Venn diagram, the details written in that Venn diagram will help you. Those who will belong on one side will be written on the other end of the circle, and those who are belonging in those categories, they like both the activities, they belong in both activities in that given survey, will be written at the point of intersection of the two circles. Then those who do not like any of them will be written outside the two circles at one point in that given frame. So that is what is referred to as a Venn diagram. So from this Venn diagram, we can answer some few questions concerning the probability. So this is the Venn diagram I have. I want to use the Venn diagram to answer the following questions on probability. So the first question that we are coming up with, we need to find out how many people were surveyed in this given survey activity that was being carried out. From our Venn diagram, we find out how many people were surveyed. So to get the number of people who were surveyed in the diagram, then it means that we simply get the total. We have the people who like coffee. We have those who like both coffee and tea. Then we have those ones who like tea. And we have those ones who do not like coffee and at the same time do not like tea. So this is indicated there. So we find we have 15 plus 20, which gives us 35. 35 plus 10 is 45. 45 plus 15, we get a total of 60 people participated in the survey. Then we are asked how many people from this survey like tea. So from the Venn diagram, to find out those who like tea, then we have 10 who like tea. We have 20 who like both tea and coffee. So it means still they like coffee, but at the same time they like tea. So how do we get the total of people who like tea? So we will have those who like both tea and coffee and those who like tea only to get the total. So we have 10 plus 20, which will give us a total of 30 people who like tea. From our Venn diagram, we can find the probability What is the probability that a person picked at random likes tea? So we need to know what is the total number of people who participated in the survey. We find out that the total number of people who participated in the survey were 60. Then what is the total number of people who like tea from the survey? Those who like tea from the survey, we got that we have 20 who like both tea and coffee. Then we have 10 who like tea only. And we get that the total number of 30 people like tea in that given survey. So probability that the person selected at random from this given survey likes tea will be obtained by 30 out of 60. And we get that 30 over 60 simplified, we will have 1 over 2 as the probability that the person selected likes tea. So what are we saying? We've been looking at the Venn diagrams, and the two-way tables. And we get that after an experimental probability has been done, you can simply represent your data either on a Venn diagram or a two-way table. Then this will make your data that has been collected a bit easier to work with when you're solving questions involving probability. So two-way diagrams, two-way tables and Venn diagrams simply makes the calculation of various probabilities in a given situation easier. So it is good if after collecting more than two or more outcomes in a given situation, represent your data on a two-way table or on a Venn diagram. Then after you've represented the data on a two-way table or a Venn diagram, you will be able to solve the various probabilities that will be in that given situation. So that is all to do with the Venn diagram and a two-way table. Thank you.